Guys, this is a Polyglot programmer, and I'm here again solving this problem. I've solved this in the past, but I decided to give another crack at it today. And this is a very common problem, as you can see here, like by the companies, that the amount of people that said that they got this question in an interview or something related to this. So this is and it's a very cool problem to solve. So let's get down to it. So basically, it's telling us to add two numbers on different linked lists that you get. Yeah. So given two non-empty linked lists representing two non-negative numbers, non-negative integers, the digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers in return linked list. So on this example here, so he has a 2, a 4, and a 3, and he has another linked list which is a 5, a 6, and a 4. So as you can see here, basically he wanted to add the 2 and the 5, 4 and the 6, and 3 and 4. 4 and 6 it's a 10, so but you can see that 3 and 4 is a 7, and it has 8, so that means that it has a carry. So basically, so this is also, you can also see this is a two-pointer problem, but not a sliding window one, because we're dealing with two different lists. But you basically have this, you start with the pointers at 0, and then you sum up this guy. Okay, this is 7, you have no carry, and then then you move this, and this is a 10, carry 1, and then that becomes a 0, and then you have a 3 and a 4, which gives you a 7 plus the carry, which is, it gives you 8, and that's basically what you get here. And you need to return another linked list, and the explanation is that it's basically what it is. It's just simple math. So let's get down to it. So the first thing I'm gonna do here is I'm gonna define two pointers at the head of each of our linked lists, just so we can navigate the linked list. So I'm just gonna call that current L1 equals L1, and current L2 equals L2. And another thing that I'm gonna do is that I'm gonna define a head, which is gonna be used to be, I'm gonna be used to return, and I'm just gonna assign this to 0. And this is just like an empty node that it's a head, and and my answer is gonna be basically return head dot next, because whatever comes next, it's gonna be my first answer here, right? Okay, and now and then I need two extra variables here, the same way that I assign a pointers here to navigate the linked list that we have here. I'm gonna assign I'm gonna create another pointer here, that just to be able to navigate, or to add stuff to our head. And the way this works, you can just return head here, because in Python they are referring to the same address here, so that's fine. And I also need a carry, which is 0. So every time I sum two of these guys, so 2 and 5, I'm gonna sum up with whatever is on the carry. On the first try, that's gonna be a 0, and so on and so forth. Okay, so we have the boilerplate of our problem. So the next step is to iterate through our guys, right? So we're gonna iterate through L1 while L1 is not none, or current L2 is not none. Why or? Because it doesn't say here, but I did this problem enough times that I know that these guys, they can have different length. So you might get to a point where this guy has 3 or 4 items and this guy only has 2, and then you're going to keep adding zeros for whatever is supposed to be on the second one here. Right, and okay, so we got this. So while our first linked list is not none and our second linked list node is not none, now we're just gonna get the values for these guys just to make it easier for us to so we're gonna do x equals current L1 dot val if current L1 is not none, else just assign to 0. And we do the same for the 2. So if it's this guy is none, because at the end we're gonna assign the current list node to next. And if the next is none, then this guy is always gonna be 0. So it's okay. Now we're just gonna sum. So let's just call this current sum equals x plus y plus whatever is on the carry, right? So now we need to define what's the carry, right? So we don't, I mean, there's several ways to do this. An easier way to do this is just say carry equals current sum, a hard division here by 10. So for example, if it's 9 and 9, we have 18, right? We have 18. Yeah, heart, and we have an 18, and we divide this by 10, and then we're gonna get a 1 here. So if we have a 5 and a 4, if we have a 5 and a 4, then it's 9, and divide this by 10, this will be 0.9, but this will actually be 0. Getting a bunch of messages here. Interesting. Anyway, so we got our carry, right? So now what we do is that we just assign our current node dot next equals a new node, and we do sum mod 10. And then we move our current node. Current node equals current node dot next. Okay. And now it's just time for us to move the pointer on our current guys. So let's just if current L1. Again, because we might have lists of different sizes, right? If current L1 is not none, then we just move this guy equals current L1 dot next, and we do the same thing for second linked list. Sorry for all the copy and paste here. And that's it. So the only thing left here that we have to do is that after we get out of our while loop, we need to check if carry is bigger than 0. Because if carry is bigger than 0, that means that we still have something on the carry. And then we just say that our current node dot next equals list node dot carry. And then we return head at the end, and this should be it. Oh, we're getting a type. Sorry, getting so many messages here. I'm streaming this live. 924. Oh, it's this. Yeah. Okay. And that's it, guys. It's pretty good solution, faster than most. Didn't use a lot of memory. Pretty straightforward. Hope you guys enjoyed it, and see you next time. To all my 55 viewers on Twitch, that was fun. I think I never streamed to that many people, but that's it. Cheers.